So, laws of motion. So, in laws of motion, the first thing which we have to do is, so laws of motion. Now, what is motion that already we have done? What are the types of motion that also we have? So, in this topic, how and what we will do is the first thing is what is force? It is force. So, can I say that if there will be a block, suppose ये हमारा एक ब्लॉक है, एक सरफेस है, और इस सरफेस के ऊपर अगर हम लोगों ने एक ब्लॉक रख दिया और अगर इस ब्लॉक को अपन ने पुश किया या फिर इस ब्लॉक को हम लोगों ने पुल किया, सो व्हाट विल हैपन? दिस ब्लॉक विल मूव फ्रॉम पॉइंट ए टू पॉइंट बी, ए से बी पे चले जाएगा. सो वी कैन से दैट a push or a pull given to a body, a push or a pull given to a body is called as force. So we'll define it as a push or a pull given to a body, or body is called force. Okay? Called force. Now, what can be the effect of forces? Effect of force. Can I say that the force will force will change the state of motion? अब इसका मतलब क्या होता है? Will change the state of motion. State of motion. अब देखो स्टेट ऑफ मोशन का मतलब क्या होता है? अगर मान लो गाड़ी धीरे चल रही है, ठीक है, कोई पीछे से आया उसको धक्का मारती है, छोटी वाली गाड़ी, छोटी सी जो गाड़ी होती है, ठीक है, उस वैसे आराम से चल रहा है, किसी ने आके पीछे से धक्का मार दिया तो उसकी स्पीड बढ़ जाएगी, स्टेट ऑफ मोशन चेंज हो जाएगा. सिमिलरली अगर कार चलते चलते आ रही है, अगर हम लोग ने ब्रेक अप्लाई कर दिया तो कार स्टेशनरी हो जाएगी, है ना? So what we are doing, we are applying force, and why we are applying force? We are applying force to change the state of motion. Is it clear? The first thing is force can change the state of motion. Is it clear? Even we can say that force can change the change the direction direction of motion. Okay? So force क्या कर सकता है? मोशन के डायरेक्शन को चेंज कर सकता है ना? मतलब सपोज फॉर एग्जांपल अगर बॉल सामने से आ रहा है तो क्रिकेटर ने जब भी बैट से उसको हिट किया तो बॉल विल मूव इन फॉरवर्ड डायरेक्शन. पहले वो सीधा आ रहा था, वो उल्टे डायरेक्शन चलना शुरू. सो वी कैन से दैट force can change the direction of motion. Also, we can say that force can force can change the shape of body. The shape of a body. अगर तुम्हारे पास बॉटल है उसको क्रश कर दोगे तो यू आर अप्लाइंग फोर्स, एंड इफ यू अप्लाई अ फोर्स तो व्हाट विल हैपन? द स्ट्रक्चर ऑफ बॉटल विल कोलैप्स. ठीक है? So this is something about the effects of forces. Now let's talk about the laws of motion, Newton's law of motion. You all know that, फिर भी एक बार देख लेते हैं. Newton's law. Law. अब इसमें होता क्या है न्यूटन्स लॉ ऑफ मोशन में? There is a first law, first law, or we can say that law of inertia. Acha, can you tell me what is inertia? What do you mean by inertia? आइडिया है कुछ inertia के बारे में? कौन सी चिड़िया का नाम है?
I had heard of it in one of the books, but
Not an issue. ठीक है, देख लेंगे. Inertia का मतलब क्या होता है? Your table, suppose for example, in morning your table will be in hall, in the evening your table will be in hall, in the night also the table will be in hall only. ठीक है. मान लो for example किसी दिन तुम सोई हुई हो बेडरूम में और सुबह उठा तो तुमने देखा कि तुम्हारे जो हॉल की सारी चीजें हैं वो अपने आप बेडरूम में चली आई, किसी ने उसको छुआ नहीं. कभी ऐसा हो सकता है?
no.
अगर ऐसा हुआ मतलब भूत है ना? और भूत तो होता है नहीं, वैसे बोला जाता है. सो व्हाट आई मीन टू से दैट जो रुका है वो रुका ही रहेगा. आई मीन the body which is stationary will keep will be stationary and the body will be in motion. ठीक है, until and unless external unbalanced forces applied on the body. तो जब तक उसके ऊपर हम कोई फोर्स अप्लाई नहीं करते हैं वो बॉडी अपने ओरिजिनल कंडीशन में होती है. ठीक है. इफ यू keep your book on a table then the book will remain on a table until and unless you are going to apply a unbalanced force on that. ठीक है. So law inertia states that we can say that law of inertia states that the body continues to be in state of rest or uniform motion until and unless external unbalanced forces apply. ठीक है. तो सपोज जब तक यहाँ पे हम लोग ने एक्सटर्नल अनबैलेंस फोर्स अप्लाई नहीं किया देन द ब्लॉक इज नॉट गोइंग टू. सपोज इसका अगर वेट 5 न्यूटन है, ठीक है, और यहाँ पर अगर 2 न्यूटन फोर्स हम लोग ने अप्लाई किया तो मूव करेगा क्या? नहीं मूव करने वाला है ना. इट विल नॉट मूव. So it will only move when we apply 5 Newton of force or more force than 5 Newton. Is it clear? So this is the inertia. ठीक है. Now there are inertia of rest, inertia of motion, and inertia of direction. Inertia. तो ये तो था बात है हमारे inertia के बारे में. Inertia of rest जो स्टेशनरी होगा वो स्टेशनरी रहेगा. एग्जाम्पल If you keep your book, it will remain stationary. Inertia of motion. Suppose, for example, if you are traveling in a bus and the driver suddenly applies a brake, you experience an outward motion. मतलब आगे move करोगे. That is because of inertia of motion. And inertia of direction. If you switch off the fan, then fan immediately does not stop. It takes time to stop. So that is inertia of direction. Is it clear?
Yes.
और inertia of direction के लिए दूसरा एग्जांपल भी बोल सकते हो. Suppose if you are driving a car at 100 km per hour, ठीक है, and if you suddenly applies or you turns a steering, then car will skid in the forward direction only because it is trying to maintain the state of direction. ठीक है, inertia of direction. Is it clear?
Yes.
Okay. So now this was inertia of direction. Next we can say that. अच्छा, what is first law? So according to Newton's first law, so according to Newton's Newton's first law, no, everybody everybody continues to be continues to be in state of rest or uniform motion until and unless external unbalanced forces apply. Unbalanced forces apply. ठीक है? So this is Newton's first law. Now Newton's second law. So according to Newton's second law, we can say that the amount of applied force, the amount of applied force, amount of applied force is directly proportional to change in momentum. ठीक है? Change in momentum. So we can say that F directly proportional to change को हम लोग लिखते हैं dp by dt, dp by dt. So F is equals to dp is mass into velocity. So mass will be common, v minus u upon t. So which can also be written as force equals to change in velocity upon time is acceleration. Is it clear?
Yes.
Note it down.
Okay.
Done?
Yeah.
Okay. Next is next is third law. Third law तो पता ही है तुम. So according to Newton's third law, we can say that according to Newton's third law, every action has equal and opposite reaction. Yeah. Okay. So every action has equal and opposite reaction. So this was the Newton's third law. Okay. Next. Next is collision of a body. So now what collision of body basically means? Suppose there are two types of collision. One is elastic collision, another is an inelastic collision. Now there will be a difference between elastic collision and inelastic collision. एक एक करके देखते हैं पहले. Suppose for example, अच्छा उससे पहले कुछ और चीजें भी पढ़नी है. देखो ये सब तो बेसिक बेसिक चीजें थी. नेक्स्ट है हमारा और टाइप्स ऑफ फोर्सेस. ऐसे हैं तो बहुत सारे पर पढ़ाने अपने को दो ही तीन है. So types of force. So basically there are two types of forces. Contact force and non-contact. Now contact force. तो नाम से पता चलता है. Suppose for example वापस हम लोग ने सरफेस की, इस सरफेस के ऊपर हम लोग ने एक ब्लॉक रखा. अब इस ब्लॉक का वेट किधर एक्ट करेगा? डाउनवर्ड डायरेक्शन में. और इसका सरफेस जो होगा that will also act a force and that force will be in opposite direction. So one force weight will be acting in downward direction. Another will be a normal reaction acting in upward direction. अगर ये surface नहीं होता, if surface AB will not be there, then there will be no normal reaction or there will be no upward force. So here we can say that the normal force is nothing but a contact force. अगर ये surface के साथ contact में नहीं होता तो यहाँ पे normal reaction नहीं होता. ठीक है? Yeah. So the normal reaction arises due to contact between the object and the surface. Object and the surface. Even we know that frictional force is also contact force. If this body will move, suppose for example, if we apply force in this direction, there will be a force acting in opposite direction. That is a frictional force. And frictional force, अभी हम लोग हाथ को ऐसे ऐसे करेंगे तो कोई फ्रिक्शन नहीं होगा, लेकिन जब ऐसे करेंगे when there will be two surface in contact, then there will be a friction. So we can say that frictional force frictional force is a contact force. The contact. और एग्जांपल देख लो. सो कौन कौन सा कॉन्टेक्ट फोर्स हुआ? एक तो नॉर्मल रिएक्शन हुआ, फिर फ्रिक्शनल फोर्स हुआ, नेक्स्ट इज टेंशन. सो टेंशन इज आल्सो अ कॉन्टेक्ट फोर्स. सपोज फॉर एग्जांपल ये हमारा रॉड सरफेस है, एक स्ट्रिंग मैंने टाई की यहाँ पे, और यहाँ पे हम लोग ने एक वेट अटैच किया. सपोज अ वेट इज अटैच्ड. So now in this case also we can say that the weight of the body will be acting in downward direction. The weight will be acting in downward direction, and at the same time there will be a tension acting in upward direction. Is it clear? So mg and tension, these both are the contact force. Is it clear? इतना नोट डाउन करो, फिर मैं को नॉन कॉन्टेक्ट बता रहा हूँ. So this is something about the normal reaction. So in this case, you can write as N equals to mg. And in this case, you can write as tension is equal to mg. Next is non-contact force. So the force which arises without any contact. Contact, contact between two surfaces is called contact. अब इसमें क्या हो जाएगा? Best example, gravitation force, है ना? So gravitation force क्या होता है? Suppose for example, if there are two objects and each has mass m1 and m2 and the distance between them is r. So the force of attraction between these two particles will be directly proportional to product of their mass, and force will be inversely proportional to square of the distance. When we combine this, so F will be equals to or directly proportional to m1 m2 upon r square. And when we remove this proportionalities, and we will get a constant g m1 m2 upon r square. और जो g होता है, this g is called as universal gravitational constant. इसकी वैल्यू होती है fr square upon m1, and g is equals to 6.67 into 10 raised to minus 11 Newton meter square per kg square. Newton meter square per kg. इसको लिखो, ये समझा ना पक्का? And you know this law was proposed by Newton. He said that the force of attraction between any two particles in the universe will be directly proportional to product of their mass and will be inversely proportional to square of the distance. So that this is from the Newton's law of gravitation. So according to Newton's law of gravitation, Newton's law of gravitation. लिखो इसको फिर आगे बढ़ते हैं.
Okay.
ठीक है. So this was the example, basically one example. There are many more. One more example we'll see. Magnetic force. So in magnetic force, suppose for example, if we have a two magnets, and if this is a north pole, south pole, north pole and south pole, they are not in contact, but still they will repel each other. है ना? They will repel each other. So they are repelling because of a force which is a non-contact. Is it clear? So magnetic force is a non-contact force. Any doubt? Now, suppose for example, the next thing which we will learn is FBD, it is free body diagram. It is not given in your portion, but since we are preparing for MHC CET examination, so they will be definitely asking question based on it. Okay. So FBD. अब FBD में क्या होता है? इसका फुल फॉर्म क्या होगा पहले ये तो पता नहीं चाहिए. So free body diagram. Suppose for example, if I am having, अच्छा, अब तुम्हारे दिमाग में आएगा कि ये हम करते क्यों? Suppose if there is a block given and the weight is given in downward direction, normal reaction ऊपर दिया हुआ. So it is very much tedious for drawing all the times this block surface. ठीक है? So in order to avoid that, we just represent the whole diagram by of, suppose the weight mg is given, normal reaction is given. तो हम क्या करते हैं, इसको सिंपली रिप्रेजेंट ऐसे कर देते हैं. ये हमारा नॉर्मल रिएक्शन हो गया, ये हमारा mg हो गया, है ना? तो एफबीडी में हम करते क्या है, जो भी हमारा ऑब्जेक्ट रहता है उसको सिर्फ एक पॉइंट ऑब्जेक्ट से रिप्लेस कर देते हैं. सिमिलरली सपोज अगर मान लो एक बॉडी इसके ऊपर है, ऐसे रखा हुआ, ठीक है, ऐसे. So every time I'm not going to draw this. So what I will do, I will just draw the components. So this will be the normal reaction. The weight mg ऐसे एक्ट कर रहा है, इसको दो कंपोनेंट में रिजॉल्व कर देंगे. So this is theta. So this will be mg cos theta. This is mg sin theta. समझ में आया ना? तो जो ऑब्जेक्ट को हटा के we will only represent a force, then it will be called as free body diagram. Is it clear? फ्री बॉडी मतलब बॉडी को फ्री कर दिया, बॉडी को गायब कर दिया. Is it clear? Just do this. Okay. अच्छा, remaining is the another concept now that will require time to complete. ठीक है, fully concept. So we'll do that in the next class. ठीक है. Till here any doubt बेटा?
Okay.
Till here any doubt?
No. This
पक्का?
mg sine theta, right? Isn't like the direction wrong?
This is mg sin theta.
Yeah, but on the block, mg sine theta is not, like this. It's like that.
अच्छा, wait, I'll show that. So this will be mg. ठीक है, ये एंगल हो जाएगा. This will be angle. So I have said that जिसके साथ एंगल बनाएगा that will be a cos theta. So this will be mg cos theta and this will be mg sin theta. Okay, did you understood?
Yes.
Sure. Remaining we'll do in the next class. ठीक है, and we will
Okay.
keep class on Wednesday only. ठीक है, we'll try to keep on Wednesday only. ठीक है,
Okay.
bye bye.
Bye bye. Thank you.